Chemistry students, so we've just gone ahead and we've talked about lab safety, and we've talked about, some of the equipment that's in the lab to keep us safe, and some of the things that we do in the lab to help keep us safe. So now what we're going to do is we're going to go ahead to our next target, which is about some of the lab equipment. And we're going to talk about some of the lab equipment, what's it called, what's it used for, what's it not used for, and our target is to be able to identify and describe the proper use of some basic lab equipment. So let's go ahead and let's talk about some of the things that we find in the lab. First off here, let's talk about scales, okay? A scale is used to measure the weight or the mass of a substance, and in my lab, I have two different kinds of scales. I have the gray scale and the white scale. And I've always thought that the gray scale looks nicer, but the white scale is actually a better scale, and let me show you why. Let's turn them both on here. Both scales have an on button. The gray one has a combined on-off button, and the white one has a separate off button. Once they're both on, you can see the displays here, right? They both say 0 at the moment, but the gray scale says 0.0, and the white scale says 0.00, right? Which means the gray scale can measure to the 10th of a gram, whereas the white scale measures to the 100th of a gram. And that extra decimal place is pretty valuable, right? The gray scale is a fairly cheap scale, 10th of a gram. This might cost about $30. The white scale is a bit more expensive. That extra decimal place will cost you 10 times as much. So the white scales cost about $300 each. And you can, in fact, buy scales that measure to the 1,000th of a gram, and they indeed cost 10 times as much as this. So 1,000th of a gram will cost you about $3,000, right? Okay, let's take a look at the scales and look at some of their functions and how to use them, okay? First off, you never want to put a substance directly on the pan of a scale. Powders, liquids, whatever can get into the electronics and break the scale. So you don't want to put anything directly on the pan. Instead, we have what's called a weighing dish, and you put the weighing dish on there and then put the substance in your weighing dish, right? Let's turn the scales on. A lot of times students will have trouble with the gray scale. They'll put something on there and the display won't change, and they don't realize it has a lid. So make sure, if you're using a gray scale, make sure you lift the lid, right? Let's turn them back on. And you'll be able to see when I put the weighing dish, the display changes. So my weighing dish weighs about 2.17 grams. If I put it on the gray scale, it should say about 2.2, 2.1, 2.2. Okay. Now when you're using a weighing dish, there is a very helpful button on these scales. On the gray scale here, you can see a button that says 0. If I press the 0 button, it resets to 0. So you can see the weighing dish is still on there, but it's not reading its weight. I've zeroed it out. If I take it off, it'll say negative 2.2, right? Now to measure the weight or the mass of a substance, here I have some sodium chloride. What I'm going to do is I'm going to use a tool called a scupula. This is a scupula, and you're going to hold it just like it's a fork. Get some stuff out of there, drop it in. And you can see I just pulled 1.1 grams of sodium chloride out of that bottle. You can add some more. You can get it. You can take just a little bit if you're trying to get. Let's say we're trying to get 1.5. There I have 1.4. Maybe I get just a little bit more. A little bit more. And there we go, we have 1.5 grams, right? And now I have 1.6 grams. Oh well. Anyway, you get the point, right? You can add just a little bit until you get to the weight that you're looking for. On the white scale, when you use the white scale, let's put this on the white scale. The white scale does not have a button that says 0, like the gray scale does. Instead, the button says tear print. Okay, so if I put the weighing dish on there and I press the tear print button, it will zero out the scale. And then you can do the same. You can use your scupula to put stuff on there and weigh it out. Another point about these scales is if you take a lot of times with the white scales, people will mess with them and press buttons. Okay, there's the on button, the off button, the tear print button, which you now know zeroes it out, and there's another button here that says Cal Mode. Sometimes people will come in and mess with this button. Okay, see the grayscale. Nice thing about the grayscale is it can measure in several different units. It can measure in grams, like we normally will, but it can also measure in ounces and a couple of other units, right? We always want to measure in grams, and if you look at it, I don't know if you can see it on the video, but there's a little triangle that points to the G right there, and that tells me it's weighing in grams. If you ever come in and that little triangle is not pointing at the G, you want to press the Cal Mode button until that little arrow points at the G. If it's in ounces or one of these other units, you're not going to get the kind of measurement that you're looking for. So make sure it's measuring using the right unit. All right, let's talk a little bit about the Bunsen burner, right? This is a Bunsen burner. You can see it's got a little nozzle here, and it's got some little windows down here on the bottom, and I can use this and open them and close them. The Bunsen burner, you use a Bunsen burner when you want to heat something up using fire. And the way that we get fire out of this is we're going to take what's one of these rubber hoses, and we're going to take one end of the rubber hose and we're going to put it into the little nozzle on there. And then the other end of the hose, you'll find on the light counters, these guys are the gas valves, right? And we plug the other end into there, and then we turn on the gas, get some fire, and light the burner. Now right now the gas is not on. I've got the gas off because it makes this horrible buzzing noise when it's on. So usually I leave the gas off. And for that reason, we probably don't use the Bunsen burners all that much. But if we do use the Bunsen burner, you want to be very, very careful because you'll have just a flame jumping up from here. And you want to be careful that you don't set your hair on fire, or send your eyebrows off, or set your clothes on fire, or set anything else on fire, because it's just a flame jumping off from here, right? So be very careful when you work with a Bunsen burner. Working with a Bunsen burner, you can adjust the size of the flame by opening and closing these windows. You probably don't want to do it while you're holding the Bunsen burner like this. You probably want to set it down and open and close those windows to make the flame about the size that you want to make it. Okay, when you work with a Bunsen burner, you don't want to heat something up by holding it over the Bunsen burner. That's not the smart way to do it. You're going to burn your hands. Instead, what you want to do is you want to take what's called a ring stand and put it over the Bunsen burner like that. And then it's got a big hole in the top, so you can't just set your thing down on top of that. But we have a tool called a wire mesh. You can see it's a wire mesh. And you put that up on top of there, and then you can put your thing on top of that, and it heats up without burning your hands. When you're ready to take it off, you don't want to take it off with your hands because it will be hot. So instead we have a tool. It's called tongs, and these are actually beaker tongs is what they're called, and you can take that and you can pick up your beaker and you can move it and not burn your hands. Now, we probably won't use the Bunsen burner all that much in our class because the gas is kind of annoying, and usually we don't really need a flame to heat something up. Instead, we're going to use a different tool. Let's take a look at that. Okay, so we probably won't end up using the Bunsen burner all that much, but we will need to heat things up. And when we need to heat things up, usually what we'll use is a hot plate. It's a little bit safer than the Bunsen burner because there's not like just an open flame, and it's really simple and easy to use. Usually, when students have an issue using the hot plate, it's that they've forgotten to plug it in. So make sure you plug your hot plate in. And then what you do is you use the dial, you can turn it on, and it's got settings 1 through 10. Usually we'll set it to, I don't know, 4 or 5 or 6 or whatever. It'll start to get hot. It'll take a few minutes to get hot. And you can take whatever you're trying to heat up, place it on the hot plate, and it will get hot. Now it's perfectly safe to put like a beaker on the hot plate. There is some glassware that you don't want to heat up like this. And If there is something that needs to be heated and there's glassware involved that you shouldn't put on the hot plate, I will tell you. But it's totally safe to heat up like a beaker, right? Now, sometimes you want to heat something up to a particular temperature. Let's say I want to heat this up to, I don't know, 50 degrees Celsius. When you need to go up to a particular temperature, you're going to need a thermometer, right? So take a look at this thermometer. When students have trouble with the thermometer, usually their issue is that they have neglected to remove it from their case. I'll tell you, I've seen many students put this in here just like this. There is a case. Make sure you take it out of the case. Okay. And then sometimes students will put it in just like this. And this is not the proper way to use a thermometer. Right? You can see that the bottom of that thermometer is right up against the hot plate. Right? So what's going to happen to the bottom of that thermometer? It's not going to measure the temperature of the stuff that's in there. It's going to measure the temperature of the hot plate. And that's not what you want. If you do that, you're going to break the thermometer, right? I mean, because the hot plate is much hotter than the thermometer can measure. You'll break the thermometer doing that. So instead, what you do is we need to suspend the thermometer inside of there, right? So what we're going to do is we're going to take what's called a ring stand, and we'll put the ring stand right here. And they make many different kinds of things that can clamp onto a ring stand. This particular one is called a thermometer clamp. It's meant for clamping thermometers on there. So we'll put that on there. Line this up nice, and then we'll take our thermometer and put it in there. And then we can adjust this. We can close this up so that it holds our thermometer just where we want it. Or sometimes you can take this little rubber guy and put that right in there. So now you can see that the bottom of the thermometer is not touching the hot plate. It will measure the temperature of your stuff and not the temperature of the hot plate. That's the proper way to set that up. Now you'll notice our thermometers do not measure in Fahrenheit. I know most people are probably used to measuring their temperatures in Fahrenheit, but we don't use Fahrenheit in science, we use Celsius. So the only numbers on here are in Celsius. Let's talk a little bit about some of the pieces of glassware that we're going to find and use in the lab. Probably the most common piece of glassware that we're going to use in our class is the beaker. These are beakers, right? Beakers come in many different sizes. You can see I've got the little one that's a little 50 milliliter beaker. I've got a 100 milliliter beaker. I've got 150 milliliter. I've got a 250 milliliter beaker. This is a 400 milliliter beaker, a 600 milliliter beaker, and this guy back here is a 1,000 milliliter beaker. So we have many different sizes of beakers here. The beaker has a flat bottom, which makes it nice and easy to set it down. It's got a lip that makes it nice and easy to pour things out of there. And if you take a look at it, it's got a scale along the side. Can you see the scale here? We've got 50 milliliters, 100 milliliters, 150, and so on. But let me tell you a little bit about the scale on these beakers. The beakers are not meant to measure the volume of a liquid, right? These scales that you find on here are not all that accurate. You can see I have here 50 milliliters of water, and I don't know how well you can see that with me holding it. It's pretty well exactly 50 milliliters of water. And if I pour it into my 50 milliliter beaker here, hopefully you can see it, it actually comes up a little bit less than that 50 milliliter mark, right? These marks on the beakers aren't that accurate. If I put it into my 100 milliliter beaker, this mark right here is the 50 milliliter line, right between 40 and 60. If I pour it in there, it actually comes up a little bit over my 50 milliliter line. I don't know how well you can see this with me holding it up. It comes up a little bit over that 50 line, right? So these scales on the beakers are not all that accurate. They're not meant for measuring the volume of a liquid. They're just there to give us kind of a general impression of how much is in the beaker. All right, that said, the beaker can be used to, hold a chemical just to kind of store it. It can be used to perform a chemical reaction. I can mix two chemicals in a beaker and watch what happens. That's what a beaker is for. So the next one we have here is what's called a flask. And there are many different kinds of flasks. This particular one is probably the only one we'll ever use. It's called an Erlenmeyer flask. Okay. The Erlenmeyer flask, you can see it's got a nice flat bottom, makes it easy to set it down. And then you can see the flask is different from a beaker because it's got these sloped sides. These sides slope in, and then you have a neck here, right? So maybe if you're going to perform like a chemical reaction and you expect there to be some kind of fizzing or some kind of spraying or something like that, these sloped sides, they help to contain that and keep it inside of the flask rather than just spraying all over the place. The other thing that it allows you to do is to close up the flask, right? So take a look at my flasks. I have, my tiny little, 125 milliliter flask. I have the 250 milliliter, the 500 milliliter, and then the big one back here is a 2000 milliliter flask. And nice thing about a flask, because it slopes in and you get a narrow opening on the top, that allows you to take what's called a stopper and put a stopper in there. So maybe you're doing your experiment and it's the end of the class and you need to put it away. You don't want dust or something to get in there. You put a stopper on the top, leave it for tomorrow, right? And then when you come back, you can just take the stopper out and get your stuff out. When you put a stopper in a flask, you have to be careful of a couple of different things. You never want to heat a flask that has a stopper in it. When you heat the flask that's got a stopper in it, when you heat it, you're going to build pressure in there, and then if you're having a good day, the stopper will go flying across the room, right? If you're having a bad day, that stopper will get stuck in there and the flask will explode, sending shards of gas, shards of glass everywhere, and that's not going to be a fun day, right? So be careful of that. Don't ever heat a stoppered flask. The other thing that you can do with the flask is filter things. Okay, so let's take a look at the flask here. We will at some point need to filter stuff. And we have a tool here called a glass funnel, right? You can see it's got a little stem. We can set that down inside the flask. And then we'll take a filter paper and you fold the filter paper. We'll do this at some point in some lab. You open it up. And then you put it in there, and then you can pour your liquid in there. Your liquid will go through the filter paper, drip down into the flask, and filter whatever you're trying to filter. So there is a flask and some of its different uses. Oh, one more thing to mention, just like with a beaker, you see the scale on the side of the flask is not that accurate. It's not meant to measure the volume of the liquid, it's just meant to give us a general impression of how much is in there. Now, with the beaker and the flask, we said that the scale on the side is not used to measure the volume of the liquid because it's not that accurate. This here is the tool that we use to measure the volume of liquid. It's called a graduated cylinder. You can see we've got a couple of different sizes here. If you take a look, it has a much more detailed scale. I don't know how well you can see it. There's lots of tick marks on there. Makes it nice and easy to measure the volume of the liquid there. We have a few different sizes. You can see here's a 10 milliliter one. This is a 25 milliliter one. This is a 100 milliliter. And these are what we use to measure the volume of the liquid. It's called a graduated cylinder. Now some of them have on them these little rings, right? And a lot of times what I see students do is they will move the ring to what they're trying to measure and then try to pour it up to there. That's not a good strategy because it kind of obstructs your view of the scale, so you can't really see it that well. What these rings are really meant for is to kind of protect it if it gets knocked over. Right? Since the scale is more accurate, these are a little bit more expensive than beakers and flasks, and this is really just meant to protect it if it gets knocked over. Okay, another piece of glassware that you'll find you're probably familiar with is called a test tube, right? This is a test tube. A test tube is a long, skinny tube. Got open on one side. Usually the other side is a rounded bottom, which makes it kind of difficult to put down on the counter. So we make this tool right here. It's called the test tube holder, or a test tube rack. You can just stick it in there and hold your test tube, right? Smaller ones don't necessarily fit in there that great. The test tube you can use to conduct chemical reactions. We can put some different chemicals in there and see what happens to them. You got to be careful with test tubes if you're working with heat, right? The warning about test tubes: if you have something in here and you're heating it, especially over like a Bunsen burner, you never want to point it at somebody, right? Because what can happen is that liquid in there, if you're heating it up, it can start to get to boiling. And when it gets to boiling, it's going to bubble, and you know, it's a long, skinny tube, a lot like a gun, right? So what can happen is that liquid, as it starts to boil, it turns into gas, can shoot out the end, right? And if you've got it pointing at somebody, then it can shoot, you know, right in their face, right in their eye, with the nice, hot, boiling, you know, chemicals. So you never want to do that. So the warning about test tubes is never point a test tube at somebody, especially if you're heating it. Can also happen if you are performing a chemical reaction in there, right? Some chemical reactions will create heat. They'll get hot. And so, you know, if you mix two chemicals in there, especially pointing it at your face or pointing it at somebody else's face, right? They get hot, whatever's in there starts to boil, and it all comes shooting out right in your face. You don't want to do that. Okay. Test tubes, you could also put a stopper in a test tube, just like you can with a flask. And again, the warning about heating things with a stopper in them: you don't want to heat something that's stoppered because it can explode, right? So a few different things to be careful of with test tubes. Just another word about some of the glassware. I think I probably mentioned it in the lab safety video. If you break a piece of glassware, it's not that big a deal if you broke it on accident, right? It's gonna happen at some point every year. The first time something gets broken, like the whole room gets quiet, and then everybody goes, ooh, right? It's really not that big a deal. Like one of the 250 milliliter beakers costs about $3, right? If you broke your beaker doing science, it was an accident, it's not that big a deal. We're cool, right? If you break something, you're horsing around, you break it on purpose, you're not following the safety guidelines, that's a different story. In that case, we'll talk about discipline, and I don't want to go there right now, right? But if you break something just by accident, it's not a big deal. Just remember, I don't want you to clean up broken glass. If you break something, let all the people around you know that there's broken glass and come and get me and we'll clean it up. When you're done working with your glassware, you're going to want to clean it off, right? You might just rinse it off depending on how clean we need it, or you might get a sponge with soap and clean it really good, right? But when you're done working with it, don't just leave your glassware sitting around dirty. Clean it and leave it back where you found it. Okay, let's see, I think that's enough for right now. We've taken a look at some of the different pieces of lab equipment that we commonly use in the lab and some of the pieces of glassware. We've talked about what it's called, what it's used for, how to use it properly, how not to use it, and hopefully that helps us to be able to identify and describe the proper use of some of the basic lab equipment. So until next time, take it easy.